Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kisiedu. In this installment in the Developmental Mathematics series, I will discuss Addition Tactics, Part 3, Addition by Averages. To find the average of a group of numbers, find their sum, then divide by the number of numbers in the group. For example, if you have 2, 5, and 9, the average of these three numbers is their sum, 2 plus 5 plus 9, or 16, divided by the number of numbers, which is 3. So 16 divided by 3, or 5 1/3, is their average. The median is the middle number in a group of numbers that has been arranged from smallest to largest. In the group 2, 5, and 9, they are already ordered from smallest to largest, so the middle number is 5. If you have an odd number of consecutive or equally spaced addends, their average is the median, and their sum is their average multiplied by the number of addends. Let's take the example of finding the sum of the natural numbers from 1 to 9. First, write out the numbers. Since there are 9 numbers, the number of addends is odd, and they are already consecutive. Here, the median is 5, so 5 is the average, and the sum is 5 times 9, or 45. If the problem requires the sum of the first 10 natural numbers, an even number of addends, continue as we just did, then just add 10 to the result. Suppose that we want to find the sum of the 13 numbers, 570, 573, 576, 579, 582, 585, 588, 591, 594, 597, 600, 603, and 606. First, write out the numbers in consecutive order from smallest to highest in summation form. There are 13 addends, and each addend is 3 more than the previous one. Here, the median is 588, which is also the average. So the sum of the numbers is 13 times 588, or 7,644. If there are addends that do not follow the same pattern as the other numbers, just add them on at the end. In Addition Tactics Part 2, Gaussian Counting, we came across the problem of finding the sum of the first 10,001 natural numbers. Addition by averages is an even easier way of solving it. Dividing the largest even number of addends, 10,000, by 2, the 10,001 addends can be separated into 2 groups of 5,000 with 1 left over. One group of 5,000 addends taken from the beginning, the other group of 5,000 taken from the end, and the last addend in the middle, the median. So the first group will have the 5,000 addends from 1 through 5,000, and the next number is 5,001. That will be the median. The second group will have the addends from 5,002 through 10,001. The median 5,001 is the average, so the sum of the first 10,001 natural numbers is 5,001 times 10,001, which is equal to 50,015,001. To find the number of addends in a consecutive sequence, find the difference between the first and last numbers in the sequence, then add 1. It is obvious how to count the number of addends when the sequence is something like 1 through 100, or 1 through 995, or from 1 to any other number. The number of addends is just that last number. But when the sequence does not start from 1, you may have to think a bit. As one last example, let's find the sum of the numbers 1,696, 1,703, 1,710, 1,717, 1,724, 1,731, 1,738, 1,745, 1,752, 1,759, 1,766, 1,773, 1,780, 1,787, 1,794, 1,801, 1,808, 1,815, 1,823, and 1,832. We can see that there are 20 numbers to be added, and that the first 18 have a common difference of 7, meaning that the first 18 numbers are spaced 7 units apart. The last two numbers, 1,823 and 1,832, do not follow the same pattern as the first 18 numbers. Leaving out 1,815, 1,823, and 1,832 so that the larger group has 17 addends in it, an odd number. The median and average of the 17 numbers from 1,696 to 1,808 is 1,752, the 9th number. The sum of the 17 numbers is 1,752 times 17, or 29,784. The sum of all 20 numbers is 29,784 plus 1,815 plus 1,823 plus 1,832, or 35,254.